So okay, so I'm going to first tell you about the theory, what is linear regression, and then we are going to do a case study on it, and then I'm going to give you their business interpretation. Okay, business interpretation as well. Okay, I mean how we are going to make money out of it. So this is what I'm going to tell you. Yeah, Avinav, you want to say something? Yes, please. Yeah, what is machine learning algorithm? All right, machine learning algorithm is what I just told you, that for a bar of soap you are selling it at a 10 rupees. Okay, so 100 people are buying from you, so your revenue is 1000 rupees. What if I ask you, being the business owner, can you tell me if I lower down the price, how many people are going to buy from me? If I get to know how many people are going to buy from me, then I can calculate my revenue easily. But this is the future, what we are talking about, right? So, and how you're going to talk about the future? There are certain algorithms like equations which are called machine learning. So this algorithm will, if I have a lot of data, it will skim through the data and it's going to predict the future. So by skimming the data, it's going to tell us if I sell it at 9 rupees, what is going to happen in the future. This is done by an algorithm or an equation called machine learning, because the machine is going to do is going to do everything by itself. Okay, all right, great. Now let's start with linear regression. So what is linear regression? We'll understand it. Okay, okay, in linear regression, so if I ask you what is regression, okay, just a single word, what is regression? Just like a one word answer. So I will say, if I try to explain it, regression, I will say regression is a relationship. Okay, kind of romantic. So I'm sure you guys will be having your relationship status. Okay, not necessarily you will be in a relationship. You might be saying, okay, I'm a single, but in Facebook, you people keep giving, right? A committed and complicated, married, single, all those type of relationships. So regression is like a relationship. So when I talk about a relationship, what does it mean? It means two person, two human being, when they're in a relationship, that means they can impact each other. Maybe like a girlfriend and a boyfriend. Okay, they can impact each other, their happiness, their sadness. But over here we are talking about not a relationship between two human being, but between two set of numbers. What do I mean by set of numbers? It means, let me ask you a question. Please try to answer. If I tell you there are two set of numbers like your sales and price, do you think there is a relationship between a sales of a product and a price of that particular product? What happens if I increase the price? Does it impact its sales? Yes, no. It and what it does, it increases, reduces, what it does? Normally, it reduces the sales. Absolutely correct. That means when I increase the price, the sales will go down. Okay, price up means sales down, and vice versa. Price down means sales up. You're absolutely correct. But let me ask you a more difficult question. That is, can anyone tell me how do you know that if you increase the sales, I mean increase the price, sales will go down? What you just said, that is absolutely correct. But how do you get to know about it? How could you answer that correctly? Where do you learn it? I mean, I'm sure anyone could have said that. I mean, all of you. But then how do you get to know about it? Can you tell me? Absolutely correct. But how do you know that? How do you know that? Okay, difficult to explain, right? How do you know that? So you know that with your experience, you have seen that since your childhood such things are being, happening, isn't it? But but yes, but there will be lot of things which you do not have any experience with. For example, there are certain uh, genetic cells in human body, something like neurofibromin and helix loop helix. So not all of you maybe heard about these names. Now neurofibromin and helix loop helix, what happens if I increase one of them? No idea, right? But in linear regression, or in regression, in should I say, if I even if I do not know the variables what exactly they are, still the linear regression can tell us what is their relationship. Okay, so regression tells us first the relationship between two variables, and the relationship could be something like over here, when price goes down sales goes up, which we call it a negative relationship or an indirect relationship, inverse relationship. And there could be another set of relationship, maybe like sales and advertisement. So what happens when you increase the advertisement? Sales are more likely to go up, is it not? It's more likely to go up. So we will call it a positive relationship or a direct relationship. That means when advertisement goes up, sales will also go up. When advertisement goes down, sales will also go down. So they will both move into the same direction. Over here, sales and price, they will move into the opposite direction. Clear up to this much? Any question, anyone? And you have another type of relationship, that is, if I talk about sales and maybe price, I talk about price of iPhone. Okay, if the price of iPhone goes up, what will happen to the sales of potato? Do you think it's going to have any impact? No impact, right? So we will say not negative. There is not going to be any impact. Do you think if tomorrow iPhone, Apple increases the price of an iPhone, do you think there is going to be any impact in the sales of an potato? No. So no relation. Exactly. No relation means zero relation, no impact or zero impact. Okay. These are the three types of relationship what we can have in regression. And now regression, linear regression not only tells us about the relationship. So if I go to my client and tells them, okay, if you increase your price, sales will go down. So he will say, okay, I'm happy to know that, but I would have been happier if you could also tell me, if you also could tell me that if I increase my price by 10%, the sales goes down by how much? The quantification. Okay, that means if I say if I increase the price by 10%, sales will go down by 1%. Then probably I think it makes sense, I will increase the price. Okay, but if you think, okay, if I increase my price by 10%, sales will go down by maybe 50%. Okay, does not make much sense. I should not increase my price then. This is called quantification. Both of these things will be revealed to me by linear regression. Clear? Now next point is how linear regression works at the back end. For example, if I tell you there are certain numbers in sequence 1, 4, 9, 16, 25, some number 49, can you tell me what is the missing value? Anyone? What do you think in this sequence? 36, absolutely correct. You are bang on target. 36. Just I have done it a square of all the natural numbers. But then, can you tell me how do you get to know that it's going to be 36? How do you get to know that? So, consciously or subconsciously, you are trying to figure out the pattern or trend among these numbers. Is there any trend? Is there any same pattern among all the numbers? You figured out, okay, so if you keep on squaring all the numbers, you're getting the same thing. So it has to be 36. Absolutely correct. But I mean, there are 6, 7 numbers, you could say that. What if there were about 1 million rows of numbers? I mean, it would not have been so very easy to do that, right, mentally? Okay, so we would have required Shakuntala Devi there probably. And what if we had about 10 million rows of numbers? Even Shakuntala Devi would have found it difficult. Okay, but for that we require something more mathematical, which is a linear regression. Linear regression, what it does, it exactly figures out by the trend or the pattern among the numbers. For example, your client has given you this set of numbers, sales and advertisements. So they are saying when you had advertised for 5 rupees, you could achieve a sales of 62 units. When you had advertised for 10 rupees, your sales were 100 rupees. Maybe you are selling a Bisleri water, okay, a packaged drinking water. So when you advertise for 5 rupees, you could sell about 62 bottles of water, 10 rupees, 100 bottles of water, and 16, 148, I mean, so on and so forth. So your client wants to know, can you tell me that if I advertise for 20 rupees, how much sales I'll have? Can you tell me from this data set? So this is your business question, how much will be the sales when you are advertising for 20 rupees? You understand the question? Yes, no? You understand the question? So I'm saying you have a business. On the previous days, you advertise for 5 rupees or $5, and you could achieve a sales of end of the day you could see that you could sell about 62 bottles of water bottles. This much clear? You advertise for 10 rupees. Okay, you create certain posters and put it over, I mean, in your neighborhood. So more people get to know that, okay, you're selling packaged mineral water, and more people will come to your shop, and you end up having 100 bottles of waters. In this way, on different days, you have seen for different amount of advertisements, you could achieve different bottles of sales. Right? Now your client asks, can you tell me if I advertise for 20 rupees, what will be my sales? You understand the question now? Okay. For anyone else, if you have any problem, please ask. Please let me know. Okay, please tell me I don't understand and I'll explain again, no problem. Okay, but then how do I get to know that? How do I figure it out? Okay, and let's imagine that your client, he knows that when he had advertised for 20 rupees, he could sell 200 bottles of water, but he had not revealed this fact to you. Okay, it has not been revealed to you. So what happens, your actual sales is 200, which you don't know. You need to predict the sales. Okay, and when your advertisement was 20, you don't know that. You need to predict what will happen, what will be my sales. One more thing I just need to tell you, that between price and sales, when I said that if you increase your price, you said sales will go down, which is absolutely correct. Alternatively, can I say that if I decrease my sales, price will go down? What do you think? Can I say that? Or if I increase my sales, tomorrow I'll increase my sales and price will go down? No, you cannot say that, because it's your own product. Okay, tomorrow you want it, you go, tomorrow you open your shop, you say I will not sell it, I will increase the price by 10%, 20%, 50%, whatever. But can you influence the sales directly? Can you guarantee that tomorrow I'll double up my sales? No, not possible. So that means what? Sales will be depending on price, is it not? You can manipulate the price and expect that the sales will change favorably. And tomorrow it's my own product. If tomorrow I want to increase the price, I can guarantee that tomorrow, from tomorrow, the price will go up. No one can do anything. Whether people will buy from me or not, that's a separate thing. But price will be higher, price will be increased. So we will call sales as my dependent variable, which depends on price, whereas price as my independent variable, which does not depend on anyone. All right. Similarly, over here, sales is my dependent variable and advertisement is my independent variable, which influences the sales. Okay, clear? Now my question is, if I change my independent variable, that is advertisement, what will happen to my dependent variable, that is sales? So I need to predict it. Okay, now how do I do it? So what linear regression will do is, all the data points whatever we have, okay, we also had a weird data point. I mean, you advertise for 5 rupees, you could sell 62 units. Here you advertise for 5 rupees, you could sell about 700 units of bottles of water. Okay, still you have a weird thing in your data set. So we need to, get rid of it. But then how do I identify? So I'll come to that. So what it's going to do is, it's going to plot all the data points on a piece of graph. Okay, just these data points: 5 rupees advertisement, 62 sales, 10 for 100. So we are just going to plot it on a piece of graph. These are all the data points. So now our intention is, we are going to draw a trend line or a pattern which is going to pass through all the data points. Okay, just like the missing value example. So you are trying to figure out a pattern. Okay, same pattern in which all the data points will fall. So if you do a square, all the values are going to fall in the same line. So similarly we are going to do that. So we can draw a trend line something like this, but this is forbidden to draw, because the word linear, in linear regression, the word linear means straight. Okay, so in this algorithm, it has forbidden you to draw a straight, a curve. It has to be a straight line. But now a straight line to join all the data points could be, I could draw a straight line maybe something like this, or a straight line something like this. Okay, So what is the ideal scenario? Can you tell me? So if the line has passed closer to the data points, that is better, or if the line has passed far away from the data points, that is better. So my trend line closer, absolutely correct. But now in these two lines, or in that case if I draw a third line, so is it possible just by looking at it which line has passed closer to the data points? Not very easy, right? Just by looking at it. So we are not going to do it in this way. So there is a calculation, and all these calculations what I'm going to show you, everything will be done at the back end by Python. You're not going to do anything about it. Automatically it will be done by the algorithm. But just to understand what it does, for all the possible lines that could have been drawn through this plane, I will do this calculation for all the possible lines. So from each line I will check the distance from this data point to this line. Okay, the shortest distance, that is the straight distance. So from here I draw a curve something like here, so that will be a long distance. So the shortest distance will be a straight line, which what we call a perpendicular line, means straight. Okay, the closest distance. So as you said that the if the distances are higher, then that is not correct. If the data points are closer to the line, that's better, right? So what we are going to do, some of the data points are above this line, some of the data points are beneath this line. So if I try to add up all the distances, some distance will be in negative, some distance will be in positive. So we are going to square them up. Otherwise with positive and negative they are going to nullify. We are going to square them up. Okay, and then we are going to add them up. Now you tell me, there are three lines maybe A, B and C. Line A, when you have squared them and you have added them, you get it as like 652. For B this is 425. For C this is 857. So something like that. So out of A, B, C, which is the best line? Can you tell me? What do you think? These are all the distances. What do you think which is the best line? 425, absolutely correct. B, because this has the lowest distance. Okay, so the algorithm or the Python is going to do it everything, and it will directly give you this is the best fit line, which is passing closest to all the data points. Okay, now in order to solve this line, do you still remember what was our business question? How much will be my sales when my advertisement is 20 rupees? Right, this was our business question. So once we have drawn the line, so what we are going to do is, so there is something called a regression equation. Okay, how we are going to figure out how much will be my sales? That's going to be easy, because in this line we will check if advertisement is 20, so 20 intersects in this line over here, and which point in the sales intersects over here, which is going to be close to 200. May not be exactly 200, close to 200, but we are not going to do it just by checking with our eyes, which is very difficult to say. So we can figure it out with something called a linear regression equation. It's very simple. Okay, this is y hat equals to b0 plus b1x plus e epsilon. So what are these things? We'll understand. What is y? Y is the actual data point, actual value of sales. We usually denote them with y. And the predicted sales, what we are going to predict, actually we denote it with y hat. Okay, this is with y hat. And the independent variable advertisement, we call it as x, the independent variable. Okay, the actual dependent variable is y, the predicted dependent variable is y hat, and the independent variable is denoted as x. So now you understand y hat, we are going to figure out y hat, the predicted sales. B0 is what? the linear regression equation, wherever it intersects with the y-axis, this point is the value of b0. Now your next question will be, how do I know what is this value? Whenever you run it in Python, Python will tell you what is the value of this point. In this case the value is 4. Python will give you this number. Okay, and the machine has fitted this line. This is what that's why it's called machine learning. So machine will fit this line, the closest possible line, and tell you what is the value of this one, that is b0. And b1, it will also give me a value of b1, which is 9.5. So what do we understand from 9.5? Do you remember what are the two things we can understand from linear regression? Relationship and quantification. These are the two things we can understand, isn't it? So how do I understand the relationship? Look into the sign beside this value. This value is called a coefficient. Can you tell me what is the sign beside this value? Positive or negative? What do you think? Anyone? Positive, no sign means positive, absolutely correct. If this sign is positive, b1, it means your x has a positive relationship with y. That means x means independent variable advertisement, y is sales. That means if you increase advertisement, sales will also increase. Okay, just by checking the sign beside it. And the quantification, we also get to understand the quantification, and that is quantification is 9.5. That means if you increase x by 1 unit, so you advertise for 1 rupee, your sales will be 9.5 units. Okay, just simple unitary method. If advertisement is 1 rupee, sales will be 9.5 units. And now we will get back to our original business question. How much will be the sales when your advertisement is 20? So if advertisement is 1, sales will be 9.5. So how much will it be when it's 20? So I will simply put these values in this equation. So the value of x is 20, independent variable, and b1 is 9.5 because this is the coefficient what we have gotten, and b0 means even if you do not advertise anything, still there will be some amount of sales, isn't it? So that is called base sales. Okay, that is called b0. And even if you don't advertise anything, still it seems that every day 4 bottles of packaged drinking water will be sold from your shop. Maybe just the people residing beside your shop will come to buy from you. And this is called a incremental sales. This is an additional sales that will happen due to the advertisement. Okay, with per unit of advertisement you are going to have 9.5 units of sales. So your sales, predicted sales will be, if you solve this equation, 9.5 into 20 plus 4, 194. All right, which is called y hat, which is 194. Now you tell me, is it 100% accurate to my actual sales, my predicted sales? Yes, no? What do you think? It's not 100% accurate, right? So there is a deviation from it. This deviation is called a residual value. Okay, a lot of noises are coming. Yeah, thanks Somnath. Now this is called a residual, which is denoted by this epsilon. Okay, this is called a residual. So we can very well understand in a linear regression, if these residual values are lesser, better the model, better the equation. Ideally it should be 0. Okay, higher this residual, that means more inaccurate is my predicted value. Okay, and this data point is called an outlier. That means it's a one single data point which is going to jeopardize my entire model. So this outlier data points like an exceptional data point, I'm going to remove it from my model. All right. Residual is you understand the predicted value. This much you understand. And I told you the actual data point was 100. 200. So your actual was 200 and you predicted it to be 194. So your prediction, is it 100% accurate? No, there is a deviation, there is a difference. That difference is called residual, which is denoted by this letter epsilon. Clear? And now the outlier means, for example, during in Kolkata during Durga Puja, do you know what all the type of foods that are being sold? Fast food, maybe noodles, fried rice, egg roll, chicken roll, ice cream, fuchka, all this stuff. Have you ever seen people selling caviar? Do you know what is a caviar? So this is called a caviar. Okay, there is a fish which is found in Caspian Sea called sturgeon fish. These are the egg of that fish. Okay, one of the most expensive food in the entire world, which is going to cost you something around $10,000 per pound. That means $20,000 per kilo. So do you think, I mean, have you ever seen people are selling caviar? No, because very unique, and who is going to buy? Does that mean that nobody is there in Kolkata to buy this? Definitely people are there. Saurav Ganguly can buy it. Sanjeev Goenka can buy it. But they are the exceptional cases. Right? People like you and me, we cannot afford it. Another example is there was a demonetization few years back. Did you face problem in demonetization? I am not getting into the political debate whether it was correct or wrong. Leave it aside. But did you face problem during demonetization? You faced problem. You faced problem. But I can say there are a lot of people who never faced any problem with demonetization. Do you think Mukesh Ambani faced any problem? Do you think Adani faced any problem? No. But just because Mukesh Ambani, Adani, Shah Rukh Khan never faced any problem, does that mean that we will say no, there were no problem in India? No, because these are the people who are exceptional. Is it not? We are not going to do any analysis based on them. Exceptional cases. So outlier is like an exceptional case. So this data point is an exceptional case, not normal. We are not going to do our analysis based on an exceptional case. That is called an outlier. Clear? And now your next question might be, how do I know which data point is an outlier? That I will come to that and I'll show you how to do that. Okay? When I'll do a case study. Clear up to this one? Anybody has any question? Clear, right? Okay. Yes. Yes, B1. Yes, B1. B1 is written beside X, right? And X is your advertisement. So with B1 we can understand the relationship with advertisement and sales. How do I understand? Check the sign. It is positive. No sign means positive. That means X and Y are having a positive relationship. That means when you increase X, Y will also increase. When you decrease X, Y will also decrease. This much clear? And increase by how much? If I increase X by 1 unit, means if I advertise for 1 rupee, then your sales will be 9.5 units of sales will be there. So what will happen if I advertise for 2 rupees? So 19 bottles of water will be sold. 9.5 into 2. Now you understand. Clear up to this much? Okay. Now we will foray into another concept which is called multiple linear regression. What does it mean? It means my sales not only gets impacted by my own price, also but by my competitor's price. Okay. For example, suppose you are buying from Shopper Stop. Okay, you are buying your clothes from Shopper Stop, and one fine morning you are planning to go to Shopper Stop to buy some clothes, and you find in pantaloons there are some discounts going on. So don't you feel, I mean, a lot of people will go to pantaloons instead of Shopper Stop? What do you think? Yes, no? Yes. So that means Shopper Stop, they have not changed their price, but just because Pantaloons is one of their competitor, they have changed their price. That's why the sales of Shopper Stop will go down. Is it not? So that means my sales is not only getting impacted by my own price, but also by my competitor's price. Correct? You understand this one? But not everyone will be my competitors. Like, if you are accustomed with buying clothes from Shopper Stop and you see there is a some discount going on footpath. In India, I mean, a lot of garments are being sold at footpath as well, right? A person who is accustomed with buying Arrow shirt or maybe Louis Philippe shirt from Shopper Stop, do you think there is a discount going on in footpath? So people are not, rather than buying from Shopper Stop, will go to footpath? You think so? No, right? So footpath is not a competitor of Shopper Stop. Okay? But Pantaloons is a competitor of Shopper Stop. So my sales can be influenced not only by my own price but also my competitors price as well. So I need to take care about my competitors as well. So you will find whenever Pantaloons will give a discount, Shopper Stop invariably they will give a discount. Otherwise, I mean, their sales will be snatched away by Pantaloons and vice versa. When Shopper Stop gives a discount, Pantaloons will also have to give a discount. No way out. Okay? And there are so many promotions going on in the market. Buy one get one free. Okay, buy one get a toy, something get free gift. Why there are so many different promotions? Because there are a lot of products which are being influenced in a different way by different products. Okay, for example, suppose if I say that uh, Maggi noodles. You understand Maggi noodles? Can you tell me who are the target customers of Maggi noodles? Traditionally, the children, isn't it? The children. So, so Maggi noodle advertisements. So definitely in their advertisement they will show you the children. So there are a lot of people now. You might say, okay, bachelors, they will have Maggi noodles lot many times. When I was a bachelor, even I used to survive on Maggi noodles, but they are not their traditional target customers. That's why in an advertisement they will not show you that a bachelor is having Maggi noodles and feeling very refreshed and going to the office. They will not show it to you. Okay. So what Maggi Noodles will do as their promotion, a few times back also I was saying that if you buy Maggi Noodles, you get a Hot Wheels car free, some toy car free as a free gift. because they understand if you give a free gift like this, and the kids are going to get influenced, okay, and in return they will influence their parents to buy Maggi noodles just to get this toy car. Okay, just like Kinder Joy. You have this one, right? Kinder Joy. So just because there is a very small plastic toy, Kinder Joy is not at all cheap. It's pretty expensive. Okay, I mean in proportionately in comparison to its competitors. But just because there is a small toy in it, the kids are going to get influenced. They will always keep on saying that I want this Kinder Joy. But the same type of promotion is not going to be effective if I say for a bottle of whiskey. So do you think for a bottle of whiskey, if people give you a toys, some free gift, people are going to buy it? No, right? So who are the people who are buying whiskeys? Adults and mostly men. Okay. So in whiskey, people will require maybe something like a price off for maybe if I say Johnny Walker Black Label, which is let's suppose about 5,000 rupees. You give it a free gift, maybe a wine glass. People are not going to get influenced. You give them maybe 500 rupees price off. You buy it for 4.5 thousand rupees. People will, I mean, chances are high that people will buy it. Okay, so similarly for all these different promotions, we need to figure out which promotions are impacting my sales in the most appropriate manner, in the most effective manner. And all these promotions, they vary from country to country, geography to geography, product to product. Not the same promotion is going to be equally effective for all. So all these things we can figure it out. All right, clear up to this much? Now I will get into another concept, that is like a dummy variable. What is a dummy variable? Tell me something that in the room in which you are at the moment sitting at, to paint half of that room, you require 2 liters of paint. Just imagine. So how much paint will you require to paint full room? So can you tell me? Anyone? Half of that room you require 2 liters of paint. So how much paint will you require to paint the full room? 4 liters. Absolutely correct. Okay, now let me ask you something. Okay, if I ask some work, if I ask Somnath to do some work, Somnath will take about 10 days. Okay, suppose. And now if I say Somnath and Supriyo both together will do this work, can you tell me how long I mean you both of you together will take? You cannot say. Okay, let me tell you. Is it not possible that what Somnath was doing, when I add Supriyo, Supriyo has no idea about this work? He just cannot help. So Somnath will just end up having 10 days itself. Possible, right? Or it might so happen that Supriyo is such an expert in this work, when he comes along, he shows it how to get it done maybe in 4 days. Or Supriyo has no idea about this work, so when he tries to help, he actually messes up, and Supriyo Somnath ends up getting 12 days. Both the scenarios are possible, isn't it? What do you think? It all depends on the efficiency of these two people, is it not? Are you getting this part? But when I talked about half the 2 liters of paint and 4 liters of paint, we never had this type of confusion, because what the 2 liters of paint will do, 4 liters will do exactly the double of it. But when we are talking about human being, I mean, they are not like that liters of paint. They are all different from each other. That's why we just cannot say if Shomnath can do it alone 10 days, I mean, both of them together will do it in 5 days. We cannot say that. They are all different. Okay, that's why if I try to say if you have sales, okay, if you have some sales values and then you have some price, whatever it might be, so you can say, okay, if what if I increase the price by 1 unit, what will happen? So you can say that the reason being the price from 1 rupee and 2 rupees, the difference is 1. 2 rupees and 3 rupees, still the difference is 1. Everywhere the difference is 1. But imagine we have another variable like your education. In education, what if I have 3 types of education? Maybe graduate, postgraduate and doctorate. Okay, and I might have an impact of education on my sales. Do you think on my client's education there might be an impact on my sales, their education level? For example, if I'm selling a bottle of Scotch whiskey, do you think a doctorate customer is going to buy more of that, or on an average, or a graduate person is going to buy more of that? Or in other words, whom do you think will be earning more money? On an average, a doctorate or a graduate? Doctorate. So if you are more learned person, I mean, chances are there that you are going to, I mean, earn more money, isn't it? So that means, so if I'm selling a bottle of Scotch whiskey, if you have more money, you are likely to buy more, is it not? So the education might have an impact on my sales, but the just the way I do it with price by if I increase the price by 1 unit, I cannot do it with education, because the difference between graduate and postgraduate is not the same as postgraduate and doctorate. Here I cannot say I increase it by 1 unit, is it not? They are all different. That's why we require to create a dummy variable, what I was telling you over here. And how do you create a dummy variable? A dummy variable is an artificial variable in order to calculate or track or capture the impact of this variable. Wherever you have some characters like this, we need to create dummy variable. And how do you do that? So out of education, you can take any one of them as your base, okay, with each which you are going to compare. For example, I say I will take graduate as my base. I will not do anything with graduate, just leave it alone. So I will be creating 2 dummy variables for postgraduate and doctorate. And how to create a dummy variable? Under postgraduate and doctorate, you fill them up with 0 everywhere, both of them with 0. Okay, and under this education column, wherever you have PG, wherever you have PG, under this PG column, you just replace them with 1. That means wherever under the education you have postgraduate, here you write 1. That means these are for the postgraduate rows. Everywhere else 0. For doctorate, wherever in the original column you have doctorate, you put 1. Everywhere else 0. This is how you create a dummy variable, and once it is done, you delete the original variable. Okay, and this is how we are going to put these 2 variables in our model. And how we are going to interpret them? Suppose the coefficients are coming to be 2 and 3. It means you're always going to compare this with your base, that is your graduate. It means that if the coefficient is 2, it means when a postgraduate customer comes to your shop, on an average he will be buying 2 units more than that of a graduate. Why did I say more? Because what is the sign beside 2? Positive sign, right? That's why 2 units more than that of a graduate. What if had it been negative 3? It means a doctorate would have purchased 3 units less than that of a graduate. So you're comparing both these things with graduate because that is your base. This is called a dummy variable. Clear up to this much? Yes, no, any question? Any question? Anyone? Orijit, Avinav, Barun and both the Baruns, Moinak, Raj, Siddharth, Somnath, Supriyo. Any question? Are you clear up to this much? Okay. Now let me go to a case study and then I will just explain the rest of it. Okay. And that will be easier for you to understand. So what we are going to do over here is we have a real estate data. Okay. This is my dependent variable, price underscore house. And each row is a different house and their details are there. Okay. So what we have is the prices are given to us. So many houses are there. Okay. And for each one of them the prices are given to me. How much rainfall we have in that particular area which is given to me. City type is there. That means city type A means like a Delhi, Bangalore, Bombay, Mumbai. These are the large cities. B is like little lesser expensive, Calcutta, Pune, Hyderabad. Category C type cities like a small town, Bardhaman, Baroda. Okay. Parking type, whether you have a parking type open, not provided, covered, what sort of parkings are there. So we can understand parking type and city type should have dummy variables created out of it. We are not going to create the dummy variables manually. Everything will be done by Python. Okay. And we have all this stuff. Built up area, carpet area. You understand what is built up area, carpet area? Yes, no. So if you have a house, something like this, and the house, within the house you are also going to build the walls as well, isn't it? And the walls will also take up some area, right? So excluding the areas which has been covered by the walls, the rest of the floor area what you have is called your carpet area. And along with carpet area you also add this area where the walls have been built, that is called the built up area. Okay. So carpet area, built up area, you have it. So definitely it might impact your price of the house. Hospital distance, what is the nearest hospital from this particular house? What is the distance? Market distance, the closest market, and the taxi distance, taxi stand. Okay, all these stuff are there. And your business question is, your client wants to know, can you tell me out of all these houses which have been given, which house I should buy? Which is the house I should buy? That means which is the house which is the most reasonably priced. So I have no idea. So there are so many houses. Okay. So let us see how we can tackle this problem. So we will get into Python. So at the moment you might not be able to understand all the codes because you have not learned it. Okay, if I mean if I had taught you these things earlier, normally for the people whom I taught data science, first I teach them all the uh, all the Python programming codes. Let me increase the font size a little bit. Okay, just a second. So now probably it's visible to you, right? So now let me just, I'll explain the codes to you. So over here I am importing the packages. These are the packages which are required. Okay, you just need to run them. And wherever I have kept this file, I am just putting my path over there and importing the dataset. Okay, so this has been imported to me. All this dataset has been imported into Python. So now what I need to check over here is there any outliers in my dataset? How do I understand whether there are any outliers or not? With this describe function, it's not very clear, so that's why I'm skipping it. Although it's going to give me some basic statistics, mean, standard deviation, minimum, it's not important. We are going to have something called box plot. Okay, in box plot what it does, so within the price underscore house, for all the numeric variable except these two, parking type and city type, we are going to check for the outliers. For the rest, do I have any exceptional value? So for box plot means if I execute it, so can you see there are some circles which are appearing over here. For example, if I show you another one like taxi distance, can you see there are circles, any dots above this line or beneath this line? They are like my outliers. Okay, simple outliers. So what I'll do is, I understand there are outliers, and how do you remove that? There is a function which I have written. Okay, this is just my own nickname. You just run this function, and then what you do, I have imported this data set. I have imported this data set as in the name of data. Okay, so and the variable name is price underscore house. So what you need to do is just run this program, this code. It's going to work on every data set, and you write into the name of the function and data, the dataset name and price underscore house, and save it as data. Automatically it's going to get into the data. Wherever there are outliers, all those outliers will be removed from your dataset. Okay, so you execute it, it's done. They have been gone. And now if I put a hash, that means I make it inactive. And now if you check for this one, now see, wherever earlier there were all these outliers were there, now all the outliers are gone, isn't it? Similarly for taxi distance, I can see there are outliers. So for taxi distance also, I'll execute this one. Automatically all the outliers will be deleted. You don't have to think about it. Carpet area. So for carpet area, we can just have a look. Yes, there are outliers. So we will remove the outliers. Yes, they are gone. For built up area, first we are going to check if there are outlier values in your built up area or not, like with box plot. If there are no outliers, then do not run this code. Okay, unnecessarily more data points will be deleted. Then don't execute it just for fun. Okay, And now we are going to check if I have any missing values. Missing value means over here, so can you see if there are any blanks? Yes, we can see there are blank spaces. These are called missing values. These are not at all desirable. Okay, so we can check if I have any missing values. So it's going to show you about in percentage. So there are in taxi distance about 1.3% rows are missing. Okay, out of every 100 rows 1.3 rows are missing. So total about how many? 11 rows are missing. So about 1.3%. So we are going to delete all the rows with missing values. It's a very standard technique. How do I delete it? Just by writing data.drop_na. Execute and it will be deleted. Okay, it's done. Now if I check it, yes, there are no missing values. All right, now we are going to check over here. So it's a clean data. Now what we have to do is we need to create a dummy variable for parking type and city type. Okay, we are going to create a dummy variable. So how to create a dummy variable? You just write pd coming from pandas dot get underscore dummies data equals to name, write the name of the dataset, which is data, column, parking type, city type. Just write the column names. Automatically the dummy variables will be created. You execute that and now you check for the data. Can you see all the dummy variables with 0 and 1 Python has automatically created, whatever I just showed you over here. Clear this one? Any question? Yes, no? Clear? Mm-hmm. Mm-hmm. Dummy variables is, I told you we need to, if there are these characters, I need to take any one of their as their base. Okay, and for the rest we are going to create all these 0 and 1. Wherever you have PG, under PG everywhere will be 1 and rest will be 0. So we created that manually in Excel, right? In Python, if I just write pd.get underscore dummies and write the column names for which we need to create the dummy variables, Python will automatically create the dummy variables. And which value will be taken as your base? Alphabetically, which value comes as first? Category A. A will be considered as your base always. So under parking type, which one will be your base? Sorry, here I add a filter. So under parking type, covered is coming as your first value alphabetically. This is going to be your base. For the rest, see, Python has automatically created these dummy variables for us. We do not have to create it manually. Clear? All right. Now we are going to run the linear regression, the final model. In linear regression, what we need to do is so first give some name to it. Linear regression, I will name it as rock. You know rock, right? From WWE, you must have seen his movies. Don't tell me no. Just any name. I just like rock, so I have given his name. You can just name anything. Okay, just some name, rock. Then sm.ols, okay, it is the name of the function. Formula equals to, what is my dependent variable? Price underscore house is my dependent variable, right? That you always write first, price underscore house. Then you give this sign tilde. Okay, I hope you can see it, right? It's visible to you. Okay, then first write the dependent variable price underscore house, then just keep on writing all the independent variable names. Okay, all the independent variable names. And some of the columns you can see there were having space in them, like city type cat space b. If they are having space in them, then you need to write them by writing q within bracket and quotes, write the name of the variable. But like market distance, there are no space in it, you do not have to give a space, I mean write q, directly you can write them. But if they are having space, write q. Once it is done, dot fit, just execute the model. Okay, once it is executed, I will check for the summary. Within summary, now what are the things you need to check over here? The first thing, so I will also write it down over here, what are the things you need to check. The first thing is you need to check this probability f statistics. This is the first thing what you need to check. And ideally the value should be less than 0.05, ideally. So can you check this value and tell me, is it less than 0.05 or not? What do you think? This value? So we have lot of engineers over here, so you should have said that within an instant. Yes, no, don't know, confused, what? We have e to the power minus, right? Whenever you have e to the power minus something, means it's a very small value. First you have to write 120 zeros and then 193. Okay, so which is fine. If that means we can proceed ahead with it. Okay, so this should be less than 0.05. It is coming from a hypothesis testing. So at the moment you have not studied hypothesis testing, so I am not telling you the hypothesis, but directly I am telling you what is the thing you need to check. So it should be less than 0.05, and this is less than 0.05. 1.93 to the power minus 122 means you need to write 0.120 zeros, you need to write, and then 193. So that's how you should have it. Okay, so I have given 14 zeros, it's e to the power minus 14, so there were 122 zeros. Okay, ideally it should be less than 0.05, which is fine. Once it is checked, then what you need to check over here is, except the first line, except the intercept, all the independent variables, their p values, this value should be less than 0.05, should be. But we can see there are bunch of values which are not less than 0.05. Lot of variables are there which are not less than 0.05, right? I should remove them from my model. How do I remove them? Let's say if I want to remove taxi distance, I will go to the code. Okay, I will go to the code and I will delete taxi distance from this one and rerun the model. Okay, but since there are so many variables with p values with more than 0.05, so the next value you are going to check is the p value, which is this value. Okay, you are going to check this one as well, and this should also be less than 0.05. So there are so many variables, so which one to remove first? So then what you need to do is you need to check this t value. Wherever these values are more than 0.05, so all these values should be removed. Okay, but I'm not going to remove all of them together. I should be checking this t value. Wherever the absolute t value is the lowest, that should be removed first. So which one is having the absolute lowest t value? Can you see the built up area 0.010? So I'll remove the built up area first. So how to do that? I will copy this one over here. I will copy this one, and built up area I will delete it from my model and rerun it. See, now built up area is no longer there. Okay, now the second value I'm going to remove is, which is having high p value and the t value is the lowest, will be which one? Maybe with market distance. This one seems okay. So I will go over here and I'll delete the market distance. These are not important variable from my model, and rerun the model. Now still we are left out with few variables. So which one to remove? Maybe taxi distance. I will delete the taxi distance. Now do I have still left out? Yes, maybe rainfall. So I will go to over here and I'll delete the rainfall. So in this way you have to keep on deleting the variables till the point when all the variables are p-values are less than 0.05. No problem. So now we are done. The next thing what we are going to check over here is the r squared. Okay, and the next one is the r square. R square is closer to 0, better the model. I mean, I said just opposite, closer to 1, better the model. Okay, if r square is 1, means is the best model. R square is 0 is the worst model. Okay, now r square is 0.497, about 50%, which is a reasonably good model. Okay, and along with r square you should also need to check adjusted r square. And what does adjusted r square tell you? It's the same thing, closer to 1, better the model. Okay, 1 means the best and 0 means the worst. But adjusted r square has a problem, is like if I include some unnecessary variables, like maybe my owner's name, okay, which is absolutely of no use, but still just because I have added some extra variable, r square will increase. Adjusted r square will not increase if it's a redundant variable, it's an unnecessary variable. So what we need to check is adjusted r square and r square should be pretty close to each other. So in this case adjusted r square and r square are very close. That means we do not have any redundant column over here. Clear up to this much? Then the next part, we are done with this part. The next part what we are going to check here is, so we are done with these things. So let me delete this one or let it be, no problem. So now what we are going to do is we are going to predict it. Okay, so for each row we are going to have a predicted values. Each row will we have a predicted values, the predicted price. Okay, this was my original price and this is my predicted price, but we'll do something with it later on. For the time being we need to check there is something called VIF, variance inflation factor. So in VIF, so what we need to check over here is, if you execute this one, so in this VIF column it is called multicollinearity. It means none of the variables, this VIF value should not be more than 2. Okay, except the intercept, this one you will ignore. Can you get to see any variable which is more than 2? No, right? So definitely they are not more than 2. All right. Yes, anyone has to say anything? Anyone? Okay. Barun, can you please just put it on mute? A little background noises are coming. Which one? Tell me. Which one? VIF. Okay. So, tell me something like it is called actually called a multicollinearity. Essentially, what it means, suppose there is a farmer, okay, and there is a piece of land on which the farmer was farming, and after 1 year he was earning value by selling all the crops. He was earning 100 rupees, okay, and the farmer has two sons and they are grown up. Next year the farmer plus his two sons, they started farming the land, and they have sold all their outputs and they are earning 100 rupees again next year. So essentially, do you think these two sons, they are employed? Do you think they are engaging, but do you think they are actually earning any money? No, right? 100 rupees the farmer himself was earning when he was working alone. So now when the two sons they have added, probably it has lowered his effort, but the earning has not gone up. So that means this is called a disguised unemployment. It seems like employed, but actually they are not earning money. If you are not earning money, then you are not employed. So these two sons are redundant, right? So in my variables what we are having, so we might have some redundant variables which we are telling the same thing. For example, like carpet area and built up area, if we have these two variables, essentially they are telling me the same thing, is it not? So I could have just have only one. Why should I have both? They are doing the same thing. So how do you understand that? That by checking the VIF. If you have the two variables telling you the same thing, this VIF value would have gone up more than 2. Okay, so that's why we need to check if these VIF values are less than 2 or not. In some of the project, if your data are not so robust, when earlier I was, yes, yes, 2 is a very standard one. Okay, but it depends on the country for which you are working. Earlier I was working for China and the African countries. Okay, in the African countries the data are not so robust, obviously. I mean, they are not so developed. So then in your project, so we used to consider that as about 3 or 3 to 4, something between 3 to 4. Okay, maybe 3 or sometimes 4, something like that. But case to case, like when you are working for a company, your seniors, I mean, unless or until you are an experienced one, seniors will tell you, otherwise you just take it as a very standard 2. Clear? Okay, so I mean, that's why I keep saying that if you have any problem, please ask me and I will make you understand, but then you need to tell me if you have not understood, because I am an analyst and not a mind reader. I cannot read your minds. Okay, all right, so we don't have any problem, right? VIF, everything is less than 2. No problem with VIF. Okay, now we are going to check something. a very important thing which is called MAP. What does it mean? It means suppose your actual sales was 100 and you have predicted it to be 120. So it is not 100% accurate, right? So your predicted value is deviated by how much percent? I mean, in your school days you had done it, right? If you buy something, cost price is 100, selling price 120, what is your profit percent? 20%. So what is the formula? The formula is 100. Actually, we do it with absolute 100 minus 120, and you divide it with the base 20%. That means what? Your predicted value is 20% deviated from the actual. In this way, you have multiple rows of data. This is 200 and you predict it to be 190. Okay. So maybe 500, which you have predicted it to be 550. So each row which you have a different predicted deviation values. Now can you tell me what is ideal, whether these deviated values are higher it's better, or these deviated values are lower it's better? Which is ideal? Exactly, lower. So had it been the case that all my predicted values are exactly same as the actual, that's the ideal, right? Then everything would have been 0%. That's the ideal scenario. But it never happens, everything is 0%. Okay, so what we are going to do is we are going to take the average of this all the entire column, which is called MAP, mean absolute percentage error. This value tells us how much deviated my predicted values are from my actual values. If my MAP is 12%, that means 12% is deviated, and or in other words I can say 100 minus 12% means 88% are matching. So my accuracy is 88%. It means clear. So as yes, MAP is the error. Yes, MAP exactly average of all the deviation of all the rows. That means on an average all the rows are 12% deviated. That means if 12% is deviated, how much is accurate? 88%. Right? So as a very standard industry standard, we say anything if it is less than 20%, it's a reasonably good model. Okay, do not expect it to be 100% accurate. Okay, so we are not astrologers, but if your MAP is less than 20%, I mean accuracy figures are more than 80%, usually clients are happy with that. Now in this one we are going to calculate our MAP. So I have just written a formula. We are going to check for the MAP, which is coming to be 18.6%, right? Which is less than 20%, which is fine. Clear? Okay, so my accuracy, if it's about 18.6%, my accuracy is about 81%, little more than 81%, 81.4%, isn't it? Which is fine, which is a reasonably good model. Definitely I can vouch for this model. Okay, all right. Now before I get into the business interpretation, so let me tell you there are some technical things which we need to check. That is some of the assumptions. The assumptions are, here I calculated the percentage to calculate the MAP. Now just forget about the percentage, talk about the absolute values. Talk about the absolute values. Okay, the first one says this should be normally distributed. So I mean, when I will teach you normal distribution, I will tell you. So in simple words, there are three tests you need to do. normality test, autocorrelation, and homoscedasticity. I might have written the spelling incorrectly. Okay, for there are three tests. For all the three tests, you are going to have a p-value which should be more than 0.05. That is all you need to check. Okay, in most of the cases in real world we do not check it, this one, but theoretically which is correct, that's why I'm showing you. But in real world we hardly check it. So how to do that? It's very simple. So I have calculated all the residual values. So just run this test and you are going to get a p-value. You need to check whether they are more than 0.05 or not. Just run it and check the p-value. I mean 0.1. Definitely point more than 0.05. This is valid. So normality test, this is validated. This is more than 0.05. Then there is something called autocorrelation test. Okay, uh, so what is autocorrelation? I am not getting into that because then I require little more time, so it cannot be done in a single day. I just need to go back and teach you about the statistics and hypothesis. For the time being, I'm just telling you just to do it mechanically, understand the business, not the derivation out of it. Okay, definitely you will understand. I mean, not everything can be done in such a short time. So it requires time. So normally I take around 2.5 months to 3 months to teach the entire stuff. So but nonetheless, so again I will run it. The second value is the p value. All you need to check over here is if this value is more than 0.05 or not. So definitely this is more than 0.05. And the last one is called the homoscedasticity. Again you are going to check whether this value is more than 0.05 or not. Yes, it is more than 0.05. So all these things are validated. There are all of them are more than 0.05. Okay, so which is fine. But having said that, all these three things in the industry we don't do that. Now we will understand the business. So your client, he doesn't understand all this stuff. He understands, he knows, he wants to know, tell me which is the variable or which is the house I should buy. Or even before that, even before we go to that, we will understand what are the variables which are actually impacting my price. The business interpretation. How we do understand that? I will go back to this final model and I will check it over here. So the coefficient, this column we will understand. Carpet area, this is my coefficient. What do you think? It's a positive or a negative value? This value? Can you tell me this one? Positive or negative? This value? Positive. It means if the carpet area will increase, your price will also increase. What do you think? It is correct or wrong? Correct. Okay. How about hospital distance? This is also positive. What does it means? If your distance from the hospital, from the house increases, your price will increase. What do you think? It's correct or wrong? So the farther you stay away from a hospital, you need to pay a higher price. You pay closer to a hospital, you need to pay lesser price. Is it correct? I mean, for what? I mean, it is correct or wrong? So are you going to pay you tell me, if I tell you that you stay just beside a hospital. So I am saying, if you stay beside a hospital, will you pay a higher price? Or if you stay far away from a hospital, you pay a higher price? I mean, this is what you normally pay. Totally opposite. So that means you are willing to pay a higher price if you stay beside a hospital. Is it not? but in my model it says you pay a higher price you if you stay farther away from a hospital, which you think is not correct. These are like the yes, no, but tell me nowadays what happens? Hmm. Okay. Okay. No. Yes, so that means you are saying somebody staying beside Peerless Hospital is paying, for example, 10 rupees as, no, as rent, and someone staying far away from Peerless Hospital is paying 20 rupees as rent. But that might have happened because this one far away from Peerless Hospital might be a bigger flat. Okay, I am telling you, just imagine exactly the same flat beside hospital, exactly same flat, exactly same flat. Okay, good. You are saying if you stay far away from the hospital it should be higher priced. The other person saying if you stay beside a hospital it should be higher priced. Good. Now can you tell me the reason why do you think if you stay beside a hospital it should be higher priced, or why do you think if you stay far away from a hospital it should have higher priced? The reason why do you think so? Let's imagine it is old people. Let's imagine so. Now you tell me. Near to the hospital, but in my model still there will be old people, young people all mixed together. Still it is saying that if you stay closer to a hospital you need to pay lesser price, right? So in the real world your client will be asking you why it is so, and you need to explain that. Now when you are saying that we stay beside a hospital, it is a, you think it is a privilege, right? It is an advantage, but you are thinking from an Indian perspective, because in India it is always very difficult to get a bed in an hospital or very expensive. But on the data set on which we are working, are you 100% sure that it is an Indian data? No, right? So it might be a case this data belongs to maybe some European countries, maybe Switzerland or Netherlands. Over there, so I was there for some time. Over there, all the cities are very small cities. In Switzerland, most of the cities will take you about 20 minutes by walking to cross the entire city. Okay, and 100% citizens are insured. Okay, and in India, I mean the insurance companies are not going to pay for all those cotton bandages, ambulances, all those stuff, right? They will deduct those charges. Over there they are not going to deduct anything. For 100% people, 100% money will be paid by the insurance. It's a government mandate. And if you are sick, you call up the ambulance will always come to your house within about 5 to 10 minutes. So, or then people might not want to stay beside a hospital because you always get to see all the sick people, ailing people, isn't it? Just like saying in India, do you think if I say I will give you a house which is just beside Domino's Pizza, are you willing to pay a higher price for that? Probably not. Because even if you pay far away from Domino's Pizza, you will call them up, they will come to your house to deliver it. So why should I pay a higher price to stay beside Domino's Pizza? Anyway, they are going to come to my house. Correct? So similarly, if you know that we are working on an Indian data set, then you can yell at the top of your voice saying it is absolutely incorrect. It cannot be, and I'll delete this variable from my model. But with European data, it can be the case. Clear? Similarly, I mean, these are like the research work, and your clients are going to ask you these questions, and you need to defend yourself. Okay, so that's the reason. So in a data science, I mean, job, I mean, even for a fresher, they start their salary of around 90,000 rupees per month, 80,000, 90,000 rupees per month as a salary. Okay, about 10 lakhs, 11 lakhs per annum. And the experienced guys will be earning more than 30 lakhs, 35, 40 lakhs. Okay, that's why I mean they are paying such a high money, because the clients are willing to pay a very huge amount for these projects. Okay, so they are ready to pay millions of dollars for these projects. I mean, they are paying actually, and that's exactly how all the IT companies are making so much of money. Okay, but then you need to deliver it as well. When they are paying so much of money, so you need to deliver it as well. Okay, so similarly for city type, A was my base. So in comparison to, if I stay in a B, I will pay this much lesser amount of money in comparison to A. In C, I will pay further lesser amount of money. Similarly for parking, in comparison to other covered, for open parking, obviously I'll pay lesser amount. For not provided, I'll pay lesser amount, further less. The least amount will be no parking at all. Okay. Now if I try to figure out which house to buy, okay, so I will export it onto a local drive, and this will be easier for me to explain now. Okay, and the price underscore house, so this is my predicted values, and I will bring the price underscore house over here. Sorry. Okay, and how we are going to uh, recommend them to, so to which house to buy. So tell me, let's talk about the first row. So the you have predicted, you think this particular house should be priced as 55 lakhs, whereas the owner is asking about 66 lakhs. What do you think? It's an expensive one or reasonably priced? You think it should be 55 lakhs and they're asking for 66 lakhs. What do you think? Expensive or cheap? Not expensive. Expensive, right? Predicted means by checking every data you have predicted this should have priced at 55 lakhs. So what I'll have these residual values. Not always. Say not always. When I have predicted it, I have considered all these data, right? After considering, hmm, correct. But when my model is predicting it to be 53 lakhs for this one, let's talk about. Okay, when my model is saying to be 53 lakhs, there must be some reason. After checking all the data, all the facilities which are actually impacting your prices, after that only my model is predicting. Is it not? So normally when you are saying depends on the facilities, how in India or how in Kolkata people price their real estate? Just whatever you can quote. Is there any structured way of pricing? No, right? If you are in a hurry, if you are in a dire requirement of money, you will be forced to sell it at a lower price. So it doesn't matter whether there are a lot of facilities or not. And if you think, okay, I can wait for 3 years and you can quote a higher price, it doesn't matter whether there are no facilities at all or not. Is it not? But when the machine learning model is giving me these results, it means they have considered every facilities and every rows of data. And after doing that, my model is predicting. And I am going to believe it. Okay. So if my model is predicting it to be 55 lakhs and owner is asking 66 lakhs, it means this price is higher priced. Whereas the second one, if my owner is asking 39 lakhs and whereas my model has predicted it to be 53 lakhs, it means they are reasonably priced. This is what we are going to believe. You get this part? So having said, yes, please. Mm-hmm. Correct. Hmm. Correct. Negative values, because over here you think it should be 53 lakhs whereas they are asking for 39 lakhs. Okay, whereas here you think it should be 55 lakhs but they are asking 66 lakhs. Clear? So what we are going to do is, in order to give them prediction recommendation, so your client will not be interested in all this technical stuff, he wants only the recommendation. So what I will do, so over here I will filter it all the negative values. Let's say I put some colors in it. Okay, and then I will sort them and I will filter them. All the negative values are there because I'm not going to go into the positive values, right? They are more expensive. So now I can say this is my most reasonably priced house. So I think by checking all the facilities and everything, it should have been 56 lakhs, whereas they are asking for only 21 lakhs. Now, when the house owner is also asking the prices, the house owner is definitely not going to study all this stuff, all the data. And moreover, he will not be having the access to all the data, right? But we have done that. My model has considered all the prices, and then after doing everything, my model is predicting. So I will be saying, okay, this is your the house you should go for, and then my client might have some other requirement. Okay, give me a recommendation in a city type C, which is my most reasonably priced house. So then what I'll do is I will just uh, I'll just filter it with city type, and now I will say, okay, these are my let's say two most recommended rows of data. I mean, these are like very similarly priced. They are priced at 16 lakhs and 17 lakhs in your C, and these are the most reasonably priced house. So based on his requirement, this is how we are going to recommend. Clear this one? In the same way, I could have recommended what sort of promotions they should have done. Okay. So, I mean, for a retail client, what sort of promotions they should have done, what sort of pricing strategy they should have provided just by linear regression. Any question up to this much? Clear? So if you do not have any question, I will stop the video. Okay.